Alright, so we're going to do two examples here. Example 1, we're going to have a sequence that starts out with 3 blocks and then adds another in stage 2, and in stage 3 adds another, and in stage 4, you guessed it, adds another. So we're going to put our stages by putting n equals 1, n equals 2, n equals 3, and n equals 4 for stage 4. So let's analyze this a little bit. What do we have that is constant throughout? Well, we have this set of 3 that we start with, and we have that same set of 3 constant throughout, the same set of 3. And from stage 1 to stage 2, we're adding 1, and then we're adding another and adding another. How many tiles do we actually have in stage 1? We have 3 tiles, and then in stage 2 we have 4 tiles. In stage 3 we have 5 tiles, and in stage 4 we have 1, 2, 3, 4, 5, 6 tiles. Now let's take that and convert it over to a table. We have stage number on one side and number of tiles on the other. So we know we have 4 stages. In stage 1 we had 3 tiles. In stage 2 we had 4 tiles. In stage 3 we had 5 tiles. And in stage 4 we had 6 tiles. Now we start to see a pattern here with the numbers. So let's try to take that pattern and translate it into a formula. And the key here is to look at this first stage. How do we get from 1 to 3? Well, let's just try multiply by 3. If we take 1 and we multiply by 3, we'll equal 3. Okay, that works for stage 1, but then what about for stage 2? 2 times 3 equals 6, not 4. 3 times 3 equals 9, not 5. And 4 times 3 equals 12 and not 6. So it's not times 3. Well, what if we tried 2 times the stage number plus 1? So we have 2 times the stage number plus 1. So the stage number is 1. So 1 times 2 plus 1 equals 2. So let's try it for the next stage. 2n plus 1. And we'll plug in the stage number, which is 2, plus 1. 2 times 2 is 4, plus 1 equals 5. We already know this is not going to work. Well, let's try another one. Let's try plus 2, because 1 plus 2 is 3. So let's try stage number plus 2. So 1 plus 2 is 3. That works. 2 is the stage number, plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. Yes, we have found a formula that works for this pattern that makes it true. So, going back to our original pattern, a formula that makes each of these sequences or patterns true is n plus 2. All right, let's move on with example 2. This time it's going to get a little more complex. We will start out with a row of 4 blocks or tiles, and that's in stage 1. Stage 2, we'll add 1 block on top and 1 block on bottom. Stage 3, we'll again add a block on top and a block on bottom. And in stage 4, we will again add 1 block on top one block on bottom. I'm going to label these with our stages, N1, N2, N equals 3, and N equals 4 for stage 4. Now let's start to analyze it. Some people like to look for what's constant throughout, and I'm going to shade in these 4 blocks because you can tell these 4 blocks are constant throughout the pattern. Another way to analyze the pattern or sequence is to count how many tiles is used in each. Well, 4 tiles here in stage 1, and then we have 6 tiles in stage 2, 8 tiles in stage 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles in stage 4. Now let's convert it over to a table to further analyze this. We have stage number on the left, number of tiles on the right. So we have 4 stages here that we've diagrammed. How many tiles? In stage 1 we have 4. In stage 2 we have 6 tiles. In stage 3 we have 8 tiles. And in stage 4 we have 10 tiles. Now we need to analyze our relationships here. And like we did with example 1, it's always good to start with stage 1 and see what works for stage 1. What's a rule that would work? Well, how about 1 plus 3 is 4? Is the rule plus 3? Well, let's apply it to stage 2. 2 plus 3 is 5, not 6. We already know that the rule cannot be plus 2 or plus 3. So now let's try another rule. How do we get from 1 to 4? We can multiply times 4. So let's see if the rule is times 4, stage times 4. 1 times 4 is 4. 2 times 4 is 8. We already know that the rule is not times 4. Well, now let's get a little more creative with our rules. Let's try stage times 2 plus 2, because 2 times 1 is 2, plus 2 is 4. And that's too hard to do in our heads, so we will just write it out. 2 times the stage plus 2. Let's plug in stage 2 and work it out. Let's evaluate this. 2 times 2 is 4, plus 2 is 6. That works. Now let's try it for stage 3. So I'll write the expression down again, and I'm going to plug in the 3 for stage 3 for n. 2 times 3 is 6, plus 2 is 8. That works. Now let's try the 4. I'm going to write my expression down again, and then I'm going to plug in 4 for n and solve. 2 times 4 is 8, plus 2 is 10. That works. The rule that makes this true is 2n plus 2.